Hello, today my topic is talking about the factorial ANOVA and factorial MANOVA and use these two tests to evaluate the sample data from the SPSS. It is the cast cells. Okay, so based on the SPSS description, the cast cells data set is talking about the hypothesis sales estimates and list price and physical specification for various makes and models of vehicles. The list price and physical specification were obtained alternately from the these two websites. Okay, this is the background of the study, and let's move on to my first research question is that whether cast manufacturers and cast types will influence the estimates of the hypothetical sales in thousands. Okay, so based on this research question, I provide my 5 step of determining which method is appropriate. The first one is that what is our variables? My variables is the sales in thousand, cast manufacturers, and cast types. So the second step is that my dependent variables is the sales in thousands, which is the scale. And the next step is that my independent variables are manufacturers and types. They are nominal. And the fourth step is that I will determine their group differences. Thus, based on those 4 steps, the last step is that the appropriate method is the factorial ANOVA. Then let's move on to the assumption of the factorial ANOVA. The first one is that the dependent variable should be measured in continuous level. Based on that, based on my five step, it is correct. And two independent variables should be each consist of 2 or more categories, independent groups. So based on the same at the 5 step, it is correct. You should have independence for observations. Yeah, it also is. So also correct. Okay, so the next one, the next 3 assumption is that there should be no significant outlier. Yes, it is. So and also the next one is very important. Your dependent variable should be approximately normally distributed for each combination of the group of the 2 independent variables. So I do this test and find out that no, it is according to the data, the dependent variables is not a normally distribution. However, based on this assignment and this data, we assume that it is normal distribution. Then the last one is there needs to be homogeneity for variance for each combination of the groups of the 2 independent variables. Okay, that's all the assumption of the factorial ANOVA. So let's move on to my outcome. So based on the test of the between subject effects, we found that the cast manufacturers significantly affect the anticipated sales, which we see the p-value is 0.000, which is very less than the 0.05, which means it's very significant. However, the cast types are not significantly affect the anticipated sales, which the p-value is equal to 0.7656, which the p-value is larger than the 0.05, is much more larger, which means that it's definitely not significant. On the other side, the interaction of the manufacturer and types are significant because the p-value equals to 0.000 and it's less than 0.05, which means that when the interaction, the interaction is very significant. Okay, let's move on to my next research question. It is the whether cast manufacturers and cast types will influence cast widths and cast lengths. So my 5 step is that first my variables are widths, lengths, manufacturers, and types. And the second step is that the number of the number of dependent variables are cost wise and cost length. Both of the two variables are scales. And the next one is that independent variables, which are manufacturers and types. Both of them are nominal variables, which means that I have two scales and two nominal, and I determine the group differences. Based on that, we can say that it is the factorial maneuver. It is the best way to analyze this question. So let's move on to the assumption of the factorial maneuver. First, your two or more dependent variables should be measured at the interval or ratio level, which based on the 5-step, it is correct. Your two independent variables should consist of two or more categories independent groups based on the 5-step. Yes, it is. You should have independence of observations. Yes, it is. You should have an adequate sample size. I think it is. Yeah. There are no univariate or multivariate outliers. So yeah, it is. Then there is a linear relationship between each pair of dependent variables for all combination of group of your two independent variables. So when I try to analyze it, I found out that the manufacturers cannot put into the SPSS because it is a string variables as the system has mentioned. So I did this one I cannot determine. So let's assume that yes, they are all linear relationship between each pair of dependent variables and of my two independent variables. And the next one is that there is homogeneity of variance, covariance matrix, and there is no collinearity. Okay, that's all the assumption of the factorial maneuver. So let's move to my outcomes. So based on the multivariate tests, we found out that the cars manufacturers, which is this part, and cars types individually are very significant for the dependent variables. The p-value of the manufacturers are all equal to 0.000, which is much less than the 0.05. It means that it is very significant. And the p-value of the types are all equal to the 0.036, although it is not as small as the manufacturers, it's still less than the 0.05, which means that yes, it's still statistically significant for the dependent variables. Okay, so let's move on to the interaction of two independent variables. Based on the p-value, we can find that it's 0.799, 0.801, 0.804, and 0.405. They are all much larger than the 0.05, which means that it's definitely not statistically significant for the interactions. So yes, they are manufacturers and types are individually significant for the dependent variables, but the interactions is definitely not significant. Okay, that's all of my presentation. Thank you.